Hello and welcome, this is Adul Wadkar, your instructor. Since last few lectures, we are talking about Python collections or arrays in Python. We have already discussed about list and tuple Python collections, and this time we are going to talk about set in Python. Now when I talk about Python collection, that means I'm talking about holding multiple values in a single variable. So when I talk about the list variable, that variable is capable of holding multiple values. And when I talk about tuple or set or even dictionary, all these variables can hold multiple values at a single time, and in case of normal Python variable, that can hold a single value at a time. So we have already discussed with the list and tuple with these properties. We have checked the first important property, which is the order, and we have observed that list and tuple both are ordered, so they will follow a particular order in which the elements are placed inside the list or tuple. Secondly, if the particular collection is ordered, that means it should have indexing. So the list and tuple both are indexed. So we have discussed positive indexing as well as the negative indexing, how to access the element inside the list and tuple using positive as well as the negative indexing. And then we have discussed one of the important property, which is changeable property of list and tuple. So when I say changeable, that means I must be able to add an extra element inside the list or tuple or inside the Python collection. This is number one. Number two, it must be possible to delete or remove an element from the list or tuple. So that's an again or any other Python collection. So that means it is changeable. And third and last property is I must be able to change the value of particular element of list and tuple or any other Python collection. If all these conditions are satisfied, that means it is changeable. And we have observed in case of list everything was happening very smoothly, but in case of tuple I was not able to change the element value, and even it is not possible to add the extra element inside the tuple, and even it is not possible to delete an element from the tuple. So the tuple is strictly not changeable. And we have seen this property again, the duplicate elements. So you can have duplicate elements in list and tuple. So this is what we have tested with some parameters, and we have done lots of experimentation in Python shell. This time we are talking about this thing, set in the Python. Now it is quite different than list and tuple. There is huge difference between list, tuple and set. So number one is ordered. So this is not the ordered. Secondly, as it doesn't have any kind of order, so definitely it will not be having any kind of index. So it is not indexed. And in case of changeable property, I have said S and there is a star. So you cannot change the value of particular element inside the set, but yes, you can add the extra element inside the set, and even you can delete an element from the set. So this is what is the changeable. It's not completely changeable, but at some extent you can modify the set. And the duplicate element, so here is the huge difference between this list and tuple. The set elements, there is no any duplicate member allowed inside the set. So if you are placing some duplicate element, that element will not be accepted inside the set. So this is what the definition of set tells us. And now we are going to verify these properties on Python shell with some points. And in the next lecture we'll discuss about this dictionary, the Python set. But there is a small difference in terms of indexing, and again it is completely changeable as that of list and tuple. So we'll discuss that in later on or in the next session. We have talked about list with these points, and we have experimented these things on the Python shell. And again for the tuple we have done this, and the points which are marked red, so there was the difference as compared to the list. And here again, as we are talking about this set, first thing that we'll check whether it is ordered or unordered. So that thing we are going to test it with some experiment. And the duplicate elements will check whether the set allows to add some duplicate elements inside it, or it will raise an error, or it will be going to handle it in different manner. That's what we are going to check here. Secondly, the accessing item. So if it is not ordered, so how I can access the items or how we can provide some indexing, that what we are going to check, or whether it is not supporting the item assignment and this thing indexing, that also we are going to discuss. Secondly, we'll try to change the value of item inside the set or elements value. So we'll be checking whether it is possible to change the value of particular element inside the set, or it's going to raise an error. So that's what we are going to experiment on the Python shell. After that, as usual, we'll have some looping structure or for loop over this set, and we'll try to access the elements from that set. Secondly, we'll try to check if the particular element is existing in the set. So this is what the searching operation we are going to perform here, and we'll calculate the length of set using length function, and we'll try to add an item or element inside the set, and also we'll try to remove an additional element from the set. So based on all these 10 points, we are going to verify all the properties of set, and we are going to understand set. So without wasting any time, let's start with the Python IDE or the programming environment. So we'll wait, and here we have this Python shell. As usual, I will not go in the Python editor because I have to experiment on the Python shell only in order to understand the core concepts of the Python set. So initially, if you declare any variable like this, a equals to this 1, 2, 3, 4, 5, and if you write like this and if you hit enter, now this time this is nothing but the list, and if you print the type of it, so you will get the type of a as a list. Same thing if you do in rounded brackets 1, 2, 3, 4 and 5, and this time if you check the type of this thing, now this time it is the tuple. And same thing if you do in the curly brackets, this is 1, 2, 3, 4 and 5, curly bracket close, and if you print the type of this time it is the set. So this is how, irrespective, you can see here the data is quite similar. So here 1 to 5, these are 5 numbers, and again this is also having the 5 numbers, and this is also having the 5 numbers. Only changes in the writing. I am using here square brackets, here rounded brackets, and here the curly brackets. So even if I change the brackets, it will change its data type. So initially it was list, then tuple, and now this time we are going to talk about the set, and we are going to discuss this thing. So let's begin, and the first property of the set that we have to check, and as far as the definition is concerned, the set is unordered. It is not having any particular order. So that's what we are going to verify here. So in order to verify that, I should write a equals to, let's say 1, 2, 3. This is what I am writing, and I am taking another variable b, which is equal to, let's say 3, 2, 1. This time both the variables are holding the same data, 1, 2, 3 and 1, 2, 3, but in different order. Their ordering is different. Here it is in ascending order, and there it is in descending order. Or even you can have random order, not necessarily to have ascending and descending fashion. You can have any random ordering as well. But if I am doing like this, and I have to test the very first property of this set, that is, it is unordered. And if it is unordered, that means if I write a double equals to b, that means if I want to verify, if I want to check whether a is equal to b or not, this time it should be true. This time it should be true, as it is the set, not the list and tuple. So if I hit enter, I should, or I must get true if the set is unordered, and here we go, it is unordered. So this is how we have verified that the set is unordered. Even you can have any random thing, so 3 2 1 or 2 3 1 or 2 1 3 or anything, and if the elements are same, that means both the sets are equal. But this was not the case with the list. So if you declare the same thing in the square brackets, and again a b equals to this thing, let's say same thing, 3 comma 2 comma 1, and if you hit enter here, and if you check a equals to b, this time it is false. Okay, so in case of least or tuple, this is not the true, as they are ordered, and as this is the set, there is no ordering, they are not ordered. Only thing is that the elements has to be same inside the two different sets, and if the elements are same, that means both the sets are equal. Here, although the elements are same, 1 2 3 and 1 2 3 only, but their order is different, that's why they are not equal, they are different. So this is how we have tested the very first and important property of set, which is the set is ordered. Sorry, set is not ordered, it is not having any kind of order. Now let's go back to the second property. Now in order to test that, or in order to compare with other things, so I'll always compare with the least. So here if I take a least 1 comma 1 comma 2 comma 2 and comma 3 comma 3. So here if you check this least, now it is having 6 number of elements, and some elements are repeated or duplicates. So here the 1 2 and 3, these are duplicate elements. So as far as the least is concerned, if you print it out a, you will find it has accepted all the duplicate elements, and you can see here 1 1 2 2 3 3. So it is still having 6 number of elements, and the duplicate elements are allowed in case of least and tuple. But this time, as we are talking about set, so if I do same thing with the set 1 comma 1, sorry, this is 1 comma 1, then 2, again one more duplicate elements, and then 3, and then 3, and curly bracket closed. So if I hit enter here, so now this time it has not raised any error. So if it has not raised error, that means it has accepted the duplicate elements. Is it like that, or it's going to handle this in another different way? So let's give a check here. So I'll hit enter here, and I'll check this whether it's going to handle the duplicate elements or it's going to create a problem. So if I print here a, you will clearly notice the difference. So here it is 1 2 3 only, so it has removed all the duplicate elements, and this is how your set variable do not allow any duplicate elements. So duplicate elements inside the sets are not allowed. So that's what it is very much important to understand, that the duplicate elements you have to avoid inside the set, or even if you put any duplicate elements, it's not going to take that duplicate element. So here only you are getting 1 2 and 3. The set is like a mathematical set only, where the duplicate elements are not allowed. So if you have studied sets in the mathematics, so you must have seen that the set doesn't allow any duplicate elements, but you can have the intersection of the sets or union of the sets. So if you can recall this thing from the mathematics, you will clearly understand what is set and how the duplicate elements are not allowed. So only unique elements are allowed inside the set, and this property of set is quite similar with that of what we can say the dictionary, but this is completely different than the least and tuple. So we have verified two different properties of set, that the duplicate elements are not allowed, and again it is not ordered. Now let's try to define a set with z equals to 1 comma 2 comma 3 comma 4 comma 5, and then hit enter. And now if I have to index it, let's try to access a particular element from this set using some indexing. As this set is not having any kind of order, so that means there is no way to represent these elements in any way you can represent. Even if you write here z is equals to 5 4 3 2 1, that is the same thing with this thing. Or even if you write z is equal to 4 3 2 1 5, that is also the same thing with this thing. So if I print z of 0, and if I write or if I provide indexing, so what will be at z of 0? as it is not having any kind of order, so definitely I can't provide any kind of indexing, or accessing elements is very much difficult here. So if I print here z of 0, and I am expecting that it should print this 1 if I am expecting this thing, but this is not logically correct. If this is to be a set, then definitely at what will be printed at z of 0, whether it's going to print this 1 or it's going to print this 5, 4, because there is no fixed order that in this particular way you will have to write this set only. This is not the case with this thing. So ultimately there will be a problem here, and it should raise an error. So let's check it out, and here we go. The type error, set object does not support indexing. Though clearly it has given us the clear-cut message. Then if you are declaring any set object, that means it will not support any kind of indexing. Okay, so 0, z of 1, z of 2, z of 3, z of 4, z of 5, such kind of indexing is not allowed in case of the set element, as indexing is totally not supported. So if it is unordered, that means you can't provide any kind of indexing, and if you do not provide any, or if you can't provide any indexing, you can't be able to access the elements of the set. Though you can have a for loop to access the elements of this particular set. So this is what the important thing is, that if it is not having this indexing, so if it has given the clear-cut message that it doesn't support the indexing, then there is no way, or I should not go with positive indexing and negative indexing as that of the list and the tuple. So in case of list and tuple, if it was supporting the indexing, then I have experimented using some positive indexing and then using some negative indexing, and also I have given the range of indexes, and I have tried to print the different versions of the list and tuple. But here, as it is not supporting any kind of indexing, so I'll skip that part, because always that is going to raise this error. It doesn't support any kind of indexing. So if it is not supporting any kind of indexing, so let's try to assign. Now this is the next property that we are going to check, whether the set element will allow us to change the value of particular element inside it. For example, if I want to change the value of z of 0, now obviously there is no z of 0 term, so it should raise the error, and as far as the definition is concerned, it is not completely changeable and you can't actually modify the value of particular element. So z of 0, let's say initially it is 1, I want to make it 6. So obviously this is not the valid for the set, but still I'm going to experiment it. If I hit enter here, completely it is showing this error, set object does not support item assignment. So item assignment and indexing is completely not available for the set. So it is completely not available. You can't provide such kind of indexing and such kind of item assignment for this particular set. So this is the bigger problem and the major problem in case of the set, that the indexing is not possible, the item assignment is not possible, and the most important thing is that you can't change the value of set or value of particular element in the set. So that's how it is not changeable. But wait, we have some other properties to test, like if I have to insert one element at particular location, secondly if I have to append something in the set, and if I have to remove a particular element from the set. So I have initially discussed with you that the set is not completely changeable, but it is changeable at some extent. So you can add some element inside the set, or you can remove some element from the set. So what we can do here, we can experiment that thing here now. So let's try to add some element inside the set. So in order to add the elements, we know that there are different methods, like you can use the append method or the insert method. So append method will always add the element at the end, and the insert method, using insert method you can provide some index or the location at which you have to add an extra element inside the set. But both the methods will not work here, because as the append method, it is going to add at the end, and there is no such a start and end in case of set, because we can't say that this element is the last element and this element is the first element, as it doesn't have any kind of order. But let's try this first. So if I call this append method, and if I add something or some element, let's say I want to add 6 in the set, and if I hit enter, so clearly it is showing the attribute error for the set. The object has no attribute append. Why? Because append method tried to add at the end, and there is no start and end element in case of set, because there is no fixed order. Now let's try another method also, insert method. Now in case of this method, what it does, it will allow you to put a particular element in a particular location, but as it is the set, it doesn't have any kind of a location. That means it doesn't have any kind of index, so you can't add at particular index. So let's say if I have to add at second index and I want to add 6, so this is again not possible in case of the set, as it is showing the set object has no attribute insert, so you can't insert at particular location. But still I have said that you can add an extra element inside the set. So how this is going to happen? So this will happen with z.add method. So if you call this method and if you add an element to this set, so it's possible now. So if you have to add this 6, and if you hit enter here, no worries, no problems has occurred, and now it has successfully added an element in that z. So if you print z this time, so you will get it 1 2 3 4 5 and 6. This is how we can get it here. So this is how you can add some element, extra element inside the sets, and that's why I'm saying that it is changeable at some extent. Now let's try different thing. Now we have successfully added something in the set. Let's try to remove. Now in order to remove, as you know, there are some methods. We have used the pop method with index and prop method without any index. So whenever I call z.pop, and if I do not provide any index, so that means it will try to delete the last element from the set. But here there is no last and no first element in case of set. So as there is no order in case of set, so whether this is the last element or this is going to be the last element, this thing is not valid for set. That's why it can delete any number, any random number, and this is having no guarantee that which element will be deleted from the set. Okay, so in case of other like list and tuple, if you call this method, then you have noticed that it has always deleted the last element or the rightmost element from the list and tuple. But in case of this set, there is no such case. And if you print z this time, you'll clearly see the difference, that it has deleted one element from that. Now this is how you can delete a particular element or any random element using this pop method. Now if I have to delete a particular element at particular location, then we have used the pop method with some index value. But as you know, they said doesn't have or doesn't support any kind of indexing. It will not going to support any kind of indexing, as we have got that error before. So that means I can't call the pop method with some index. But if I have to remove a particular element, if I know the element and if I can remove it, so I can call z.remove method. And here in case of remove method, you need a particular value. So if I have to remove the 4 from that, this is the 4 which I have to remove. So if I hit enter here, and if I print the z, you will notice that the 4 is removed. That particular element is removed from the set. So this is how you can operate on the set. So if you see these properties of set, so we have checked all these things, this adding the item to the set or removing item from the set, that we have tested, but as this was marked as red, so this was not the possible. Now few more properties that we have to test, the number 6, 7 and 8, that we have to have a loop through this set. And then secondly, we have some checking whether the particular element is existing in the set, and finally we'll calculate the length of the set. So Let's declare the set one more time. This is 1 comma 2 comma 3 comma 4 comma 5, and just hit enter. So here we have the set, and now if I have to run the for loop in order to access the element, so let's for x in z. Now this will loop through this set, and this time I'll be able to access the elements of the set. And here we go, we have 1 2 3 4 and 5. So I have taken individual element from this set separately. Now if I have to check a particular element inside that, so for example I want to check 1 whether it's present in the set or not. So if I hit the 1 in z and hit enter, so it's true because the 1 is there in the set. But if I check the 6 in z, this time it is false because 6 is not existing inside the set. It is not there inside. So this is the membership operator. If you remember our operator episode or operators in Python episode, so there we have discussed a number of operators right from the arithmetic operators, logical operators, and we have also discussed the membership operators, and there are two different operators in that. The one is in operator and other one is not in operator. So this is that in operator, so it simply checks whether this one is present inside the set or not, and here it is checking whether 6 is present inside the z or not, and if it is present then it was the true, and this is the true because 1 is there, and in case of this thing it is not there, so it's false. Now next and important thing that we have to test it out, that we need to check the length of set or number of elements present in the set. So we'll count the number of elements inside the set, and for that purpose we'll use a very basic function and very popular function, length function. So you can call the length function like print length, and if you provide something in the bracket, the variable in the bracket, it's going to give you the length of it. So I want to calculate the length of z. This time there are 5 members inside the z, so here we go, we get this 5 if we call this print length of z. So now this is how we can calculate the length of particular set using the length function. But initially we have discussed like this: if I declare a set like 1 comma 1, then comma 2 comma 2 comma 3 comma 3. Now let's first do this with the list, and then I'll show you the difference. Now if this is the list, if z is a list which is having element 1 1 2 2 3 3, and if I hit enter, now clearly if you calculate the length of this z, so you will get 6 because there are 6 elements, 1 1 2 2 3 3. Okay, so as this is not allowing any duplicate elements, its length is also that much, so it allows duplicate member, that's why it will consider all the elements. Now if I do the same thing, z equals to, in curly bracket, 1 comma 1 comma 2 comma 2 and comma 3 and 3, and then curly bracket close. Now if I hit enter, we have already observed that if I hit enter there is absolutely no any error. So it accepts it, but it will not, when I print this thing, it will consider only the original non-duplicate elements. If I print the length, so what about the length then? Okay, now in this case it hasn't raised any error, but if I print the length of it, this time the length is 3 only, not the 6. So this is clear-cut difference. Here there are duplicate elements, that's why the length is 3, and if you print this, print z, you will get the difference, you'll get the actual difference, it is 1 to 3 only. So it will remove all the duplicate elements, though whenever you assign this thing it will not raise any error. For this assignment it's not going to raise any error, but when you are going to print it, it will show only the non-duplicate elements, and even if you calculate the length of your set, it will show the original elements or unique elements, the total number of unique elements inside the set. So that will be more precise statement. So when you call the length function to a set, it will give you the total count of unique elements inside the set. If there are duplicate elements, then automatically it's going to avoid that elements, and that will not be considered during the printing or during assignment. And also, if you calculate the length, it will ignore such duplicate elements while calculating the length of your sets. So this was all about the one more collection data type in Python, which is set. So we have started discussing collection data types right from the least, and then we have discussed tuple, and this time we have discussed the set. In the next lecture, we are going to discuss dictionaries. Now in case of dictionaries, everything is almost similar to that of set, and even the dictionaries will also use the curly brackets for its representation. So again, the dictionaries are not ordered, and it is similar to the set. Again, dictionary will not allow any duplicate elements, and again it is the same as that of the set. And the dictionary, the major difference is the dictionary is completely changeable. That means you can change the value of any particular element. Secondly, you can add an extra element inside it, and you can remove the extra element from the dictionary. And again, one more important difference is that the dictionary is indexed, that it has the index irrespective of it is not having any order. So a dictionary doesn't have any order as that of set, but still it has some index. So that's a very much important, interesting thing, and it will be very much interesting for you to understand how it can have some index. Now you must have a question that in mind. So I'll keep it as a suspense, and we'll see you in the next episode where we are going to discuss the dictionaries. So stay connected with me, and thanks for watching.